Okay, ladies and gentlemen, I'm a little bit behind on the problem of the week solution videos, so this is the one from February 22nd. So the first question we have is solve from 0 to 2 pi, where sine of x is equal to negative 1/2. For this one, I would highly recommend a unit circle. It's probably going to be a lot faster than anything else you can do. All right, so number one. Okay, we're going to have sine of x is equal to negative 1/2. So if we look on our unit circle, we look for where the second coordinate is equal to negative 1/2, and that occurs at 7 pi over 6 right here, and then 11 pi over 6 right here. And that's it. Very, very simple. Okay, so number two. All right, where is sine of x equal less than or equal to 1/2? So this is a slightly different question. And again, we're going from 0 to 2 pi. So what you might want to do with this one, instead of using the unit circle, you might want to use a graph. I'm going to graph it by hand. Okay. Oops. All right, let's zoom in a little bit. Okay, so that's pi over 2. Pi. 3 pi over 2. 2 pi. Okay, so, and then pi starts at 0. And then at pi over 2, it goes to 1. Then back down to pi. And negative 1. So it looks like this. Okay. So now we want less than 1/2. So 1/2 would be right about here. Now we are going to use the unit circle to help us out. So we know that sine is equal to 1/2 at pi over 6. And 5 pi over 6. So that's kind of be our markers. So we want to know where it's less than or equal to that. So we're looking for below. So just like this. So how do we write that? What's my answer? So what we're going to do is we're going to say, okay, well, 0 to pi over 6. And then it's above 1/2. And then at 5 pi over 6, all the way back to 2 pi, it stays below. So we want less than or equal to, so we can go like this. Like that. Now the reason that we don't have an equal to on the inequality for 2 pi is because if we look at the interval for the solution, I notice that it's a parenthesis. Okay, so it's number 2. All right. So the next one, number 3, again, we might want that unit circle. So number 3, we have 2 cosine squared x minus cosine equals 0. So what I'm going to do is I'm going to factor this. I'm going to solve it algebraically. So I'm going to factor out a cosine. Set each of my factors equal to 0. So, and I'm going to ask myself, since the solutions are from 0 to 2 pi, this tells me my best bet is to look on that unit circle. So where does cosine give me a value of 0? At what angle does the value of cosine equal 0? And then for the second one, where does cosine give me a positive 1/2? So cosine equals 0 at pi over 2 and 3 pi over 2. And then positive 1/2 at pi over 3. And finally, I look around the unit circle and I get 5 pi over 3. So those are my answers. Okay, now this next one's a little different, number 4. Okay, we're still going to solve it by factoring, but you'll notice it says for all possible solutions, so that makes it a little bit more interesting. So our answers are just not going to be from 0 to 2 pi, they're going to be everywhere. So I have sine squared x minus 3 sine x plus 2. Again, I'm going to solve this by factoring. So setting each factor equal to 0. And solving. Okay, so this is where it gets a little weird. Okay, so sine x equals 2 never happens. Okay, if we think of the sine curve, it bounces from 0 to 1, back to 0 to negative 1, back to 0. It never equals 2. So this particular factor provides no solution. Okay, now this one, on the other hand, sine of x equals positive 1 does. If I think of the graph of sine x, okay, what happens is I find a 1 at pi over 2. Now, since sine has a period of 2 pi, that's going to repeat every 2 pi. So plus 2n pi, where n is an integer. Okay? All right. Okay, let's talk cotangent. All right. So cotangent, where is cotangent less than 1? So I have to know the graph of cotangent. Okay? So I should graph it. Now, if you don't know what the graph of cotangent looks like, feel free to hop over to Desmos and graph it there. Okay, so cotangent has asymptotes at 0 and pi. And then again at 2 pi. Okay. Then the curve of cotangent looks like this. Okay, and its zeros happen at pi over 2 and 3 pi over 2. Okay, so that's actually 2 cycles of cotangent. I want to know where it's less than or equal to 1. So let's say here's 1. Okay, so cotangent is equal to 1 at pi over 4 and 5 pi over 4. So this point right here is pi over 4, 1. This point right here is 5 pi over 4, 1. Okay, I want to know when it's less than or equal to it, so that means below. here, and here. Okay, so I gotta write that out. So pi over 4 less than or equal to x. Now, since it's approaching an asymptote, I can't say it's equal, so we're just gonna say pi like that. And then the next section like that. And that's it. Okay. All right. So that one, okay, we can do like that. Okay. All right. So next two have to do with graphing. Okay. So what I'm going to do is I'm going to quickly switch to Desmos. Okay. Let me write down the questions for you. So number 6, we're going to solve 2 secant squared x less than or equal to tangent squared x. And then the next one, number 7, is 2 sine x cosine x less than or equal to 1. Okay. Now I am going to tell you the right answers right now. The first one has no solution. Okay. And then the next one is true everywhere. And both of these are solved. Okay, so now since we kind of know what the right answer is, I'm going to show you how to get them. Okay, all right, let's switch to Desmos. All right, so let's type these in. Okay, so I have 2 secant squared x. Okay, and then I'm going to do a second graph, tangent squared x. So I want to know where the red is below the blue. And the red is never below the blue. It's always above. So that's how I know it's a no solution. Okay? So again, that graphing it is probably the easiest way. All right? All right, let's take a look at the other one. Now, there is a little bit of a trick with this one. So we're going to go 2 sine x cosine x. Okay, now for the next one, we have to type in y equals, oops, 1. We can't just say 1. Oh, and I forgot my parentheses. Okay, so when is the red below the green? And we can be equal to it according to the formula, and that happens pretty much everywhere between 0 and 2 pi. So the red is always below the green. So my suggestion to you when you get to trigonometric inequalities is you use the graphing calculator to your advantage, especially with the more complicated ones. All right, that's the solutions for the problem of the week way back in February.